America, the nation once synonymous with speed, the birthplace of aviation, the first to put a man on the moon, and the builder of the world's largest interstate highway system, now finds itself standing on the sidelines in the 21st century. While the world races ahead aboard trains traveling at 300 kilometers per hour, the US has no true high-speed rail system in operation. Meanwhile, China has amassed over 45,000 kilometers, 28,000 miles of high-speed rail, enough to wrap around the Earth. And the US? Not a single kilometer. It's even more ironic considering the US once boasted the world's most powerful rail network in the 19th century. Today, if you want to travel from New York to Washington, you're stuck crawling along on an Amtrak train, averaging less than 110 kilometers per hour, 68 miles per hour. While across the Pacific, passengers in China cover the 1,300 kilometers, 800 miles, between Beijing and Shanghai in just 4.5 hours, cruising steadily at 350 kilometers per hour, 217 miles per hour. So what happened? And more importantly, how did China, once a laggard in industrialization, come to dominate the global high-speed rail race in just 2 decades? How did a country once so technologically behind now operate the fastest trains on Earth? This is not simply a story about trains. It's a story about power, vision, and the breathtaking transformation of an entire nation, measured in sheer speed. A nation that once tore up its first railway out of fear of Western evil spirits now stands alone as the only place on Earth where you can board a morning train in Guangzhou, have lunch in Wuhan, and sip afternoon tea by the Shanghai waterfront, all on steel tracks. The journey of China's railways from trailing behind to leading the pack is as breathtaking as the 350 kilometers per hour speeds of the CR400 AF trains streaking across the Central Plains today. To understand why China boasts the world's fastest trains, we must travel back to where it all began. Wusong, Shanghai, 1876. The 14.5-kilometer Wusong Road Railway was dismantled by the Qing dynasty after just months of operation. This early brush with industrialization was swept aside, leaving China nearly half a century behind the West. By 1911, the United States had 380,000 kilometers of tracks, while China limped along with 9,000 kilometers, much of it built by foreign companies staking their claims. The 20th century dawned with wars, civil strife, and Japanese invasion, stalling China's rail network at 27,000 kilometers by 1945. But the founding of the People's Republic of China in 1949 marked a turning point. The modest 21,800 kilometers of tracks inherited at the time became the lifeline for a vast economy taking shape. From the deserts of Inner Mongolia to the icy peaks of the Kunlun Mountains, each rail tie was laid not just for transport, but as a symbol of a nation rising from a century of humiliation. In its first 3 decades, China focused on concrete and coal, carving out routes like the Luoyang-Wenbi line through Shanxi's rugged slopes and inaugurating the Qinghai-Tibet Railway, the road on the roof of the world, at 5,072 meters above sea level. By 1980, the network reached 53,300 kilometers, enough to fuel heavy industry but still modest for a nation of over 1 billion dreaming of prosperity. A pivotal moment came in 1978 when Deng Xiaoping, during a visit to Japan, rode the Shinkansen at 210 kilometers per hour. The sight of trains slicing through the landscape like arrows sparked a bold vision. China wouldn't just catch up, it would surpass. As economic reforms kicked off, thousands of kilometers of new tracks were laid annually. State-owned enterprises were pushed to innovate, replacing steam locomotives with diesel and electric models. The Changchun factory rolled out the first CRH-1 train. In the 1990s, China's rail network grew by over 1,000 kilometers each year, a pace the United States could only dream of matching. The true game-changer arrived in 2007 with the 350-kilometer-per-hour Beijing-Tianjin high-speed line, launching a race that, even in 2025, the U.S. has yet to join with a Los Angeles-San Francisco route. Today, watching a sleek, red and white Fuxing train blaze past Xi'an's platform, it's hard to imagine this was once a land of dusty horse carts. In 2008, China had 2,740 kilometers of high-speed rail. By 2010, it surged to 5,149 kilometers, then skyrocketed to 19,210 kilometers by 2015 and 37,900 kilometers by 2015. As of 2024, China's rail network spans 162,000 kilometers, 7 times its length at the nation's founding, with 48,000 kilometers of high-speed lines, meaning 1 in every 3 kilometers is built for speeds above 300 kilometers per hour. If you isolated China's high-speed network, it would still outstrip the entire rail system of the European Union. By 2025, this figure is set to exceed 50,000 kilometers, completing the 8 vertical, 8 horizontal grid, weaving a web of high-speed rail across every city with over 500,000 people. Yet it's not just the mileage that awes the world, it's the pace of execution. China pours over $100 billion annually into rail infrastructure, more than the GDP of Laos. China pours over $100 billion annually into rail infrastructure, more than the GDP of Laos. Beneath the earth, 16,000 tunnels bore through rock, while above, tens of thousands of bridges span rivers and lakes. The 164.8-kilometer Danyang-Kunshan Bridge stretches ruler straight across the Yangtze Delta. The Qinling Tunnel pierces the spine of the Qinling Mountains, proving no terrain is too daunting for China's iron will. When length alone wasn't enough, the battle shifted to speed. The Shanghai maglev, hitting 460 kilometers per hour in regular operation and a record 501 kilometers per hour in testing, shattered commercial speed records. On the 1,300-kilometer Beijing-Shanghai route, Fuxing trains maintain a steady 350 kilometers per hour, covering the distance in just 4 hours and 18 minutes, faster than many flights when factoring in airport security and transfers. In 2024, the CR450 debuted in Beijing, hitting 450 kilometers per hour in tests and operating at 400 kilometers per hour. This energy-efficient marvel boasts 22% less drag, 10% less weight, 2 decibels less noise, and 4% more passenger space than its CR400 predecessor. China's high-speed rail carries 3.3 billion passengers annually, linking 95% of cities with over 1 million residents, from bustling Beijing to remote Xinjiang in Tibet. This revolution has reshaped Chinese society. The income gap between Shenzhen and Guizhou, once threefold, is narrowing as travel times drop to half a day. Foreign investors no longer see Chongqing as a backwater, with a high-speed ride from Shanghai via Wuhan making it accessible. The rail system itself is an engineering marvel. 16,084 tunnels, stretching 18,041 kilometers, 47,524 bridges, including the 164.8-kilometer Danyang-Kunshan and 5,470 stations. From East Asia's laggard, China now aims for 70,000 kilometers of high-speed rail by 2035 and 274,000 kilometers of total tracks by 2050. Once the latecomer, China has roared to the forefront. Achieving 450 kilometers per hour on land didn't happen by accident. Behind that speed is a meticulously engineered machine, a system of policies and technologies operating with discipline at every level. China Railway Group holds a monopoly over operations and gathers massive volumes of data. Top universities like Tsinghua and Beijing Jiaotong University are responsible for engineering and design, and CRRC acts as the world's largest train manufacturing powerhouse. This seamless machine has transformed a backward 9,000-kilometer network in 1911 into 48,000 kilometers of high-speed rail by 2024. And it's on track to reach 70,000 kilometers by 2025-2035, if the current pace of 2,900 kilometers of high-speed lines per year continues. The foundation of this success lies in what's known as the three-tier leverage policy: long-term planning, centralized financing, and institutional reform. In 2004, China's mid to long-term railway network plan initially set a target of 120,000 kilometers by 2020. When the 2008 revision raised the goal to 160,000 kilometers, Many Western analysts dismissed it as concrete delusion. In reality, China not only met its targets 3 years early, but exceeded them by 10%, reaching 176,600 kilometers by the end of 2021. From 2021 to 2035, China's new transportation blueprint calls for 200,000 kilometers of rail, including 70,000 kilometers of high-speed lines, connecting 95% of cities with populations over 500,000. To fuel this ambition, the central government has maintained an annual railway budget of over $100 billion for over a decade, even reaching $111.8 billion in 2020 during the pandemic. From 2008 to 2023, cumulative investments approached $1.7 trillion, roughly equivalent to the combined GDPs of Norway and Denmark. About 67% of that funding came from special bonds issued by China Railway Group, with the remainder sourced from preferential loans provided by the China Development Bank, local government funds, and national pension reserves. Tax incentives and government subsidies also encourage state giants like China Railway Construction Corporation, CRCC, and manufacturers like CRRC to invest heavily in R&D. As a result, railway transportation revenues reached 990.18 billion yuan, $135 billion in 2023, and are projected to surpass 1 trillion yuan, $137 billion by 2023-2025. Moreover, institutional reforms played a critical role. In 2013, the Ministry of Railways was dissolved and replaced by China Railway Corporation, a move that reduced bureaucracy and improved operational efficiency. Strict safety regulations and technical standards were also enforced, ensuring that high-speed rail lines could reliably sustain speeds of 350 kilometers per hour with near-perfect safety records. This created an ecosystem where state-owned companies, research institutes, and universities worked in synergy to rapidly push technological boundaries. Under the Company plus 18 regional bureaus model, China managed to cut 23,000 positions within 3 years, slash project approval timelines from 18 months to just 8, and pave the way for public-private partnerships on lower traffic routes. This systemic overhaul yielded tangible results. The per-kilometer construction cost of the 2022 Beijing-Wuhan route dropped 11.6% compared to the earlier Beijing-Shanghai line, despite rising material prices. New safety regulations introduced in 2020 tightened operational speeds to 350 kilometers per hour, but allowed greater voltage fluctuation, reducing energy loss by 15%. If policy was the skeleton, technology became the muscles propelling China from an imitator to an innovator. Between 2004 and 2010, China spent more than $6.5 billion licensing designs from Japan's Shinkansen E2, France's TGV Duplex, and Germany's IC3. By 2023, however, 96% of high-speed train components were domestically produced, and Chinese firms held over 15,000 related patents, including 3,200 international PCT patents. Even the critical CTCS-3 train control chip is now manufactured domestically by Shenyang's Institute 23. By nationalizing key technologies, China no longer needed to wait for Japan or Germany to boost speeds. It independently established its own 400 kilometers per hour standards. The CR400A-FBF Fuxing trains represent the pinnacle of this achievement. Power consumption stands at just 7.6 kilowatt hours per kilometer, 17% lower than its Velaro C predecessor. Noise levels in first-class cabins have been reduced to 65 decibels. Acceleration from 0 to 350 kilometers per hour takes just 382 seconds. Today, over 3,785 Fuxing and Hexi trains operate daily, carrying 3.3 billion passengers annually and accounting for 70% of all seating capacity across the network. China's approach has been distinctly Shenzhen-style, rapid, integrated, turnkey projects that transform designs into running trains within just 3 to 5 years. While America's California high-speed rail project is still tangled in paperwork, China's CRRC logo already adorns thousands of standard gauge rails throughout Southeast Asia. China's railway technology isn't limited to trains alone. It extends deeply into infrastructure. Its seamless rails, accurate to within 1 millimeter, ensure smooth rides even at extreme speeds. Its CTCS-3 signaling system, equivalent to Europe's ETCS Level 2, minimizes collision risks and boosts scheduling precision. China has also pioneered magnetic levitation maglev technology. The Shanghai maglev, launched in 2004, reaches speeds of 431 kilometers per hour, covering the 30.5 kilometers, 19 miles trip from Pudong Airport to downtown Shanghai in under 7.5 minutes. In 2021, CRRC unveiled a new maglev prototype capable of 600 kilometers per hour, which could slash travel time between Beijing and Shanghai from 4.5 hours to just 2.5 hours. China's extraordinary growth is also driven by the integration of artificial intelligence, AI, and digital technologies into rail management and operations. In 2023, China rolled out smart stations at over 200 locations using facial recognition and e-tickets to cut check-in times to under 10 seconds. 5G communication systems now enable real-time train-to-control center connectivity, dramatically enhancing both safety and efficiency. These innovations have not only improved the passenger experience, but also cut operational costs. Average maintenance expenses dropped 20% between 2015 and 2023. And China's vision doesn't end at its own borders. Through the Belt and Road Initiative, BRI, it has exported high-speed rail technology to more than 20 countries. China has rewritten its role on the global infrastructure map, from launching 350 kilometers per hour service between Jakarta and Bandung to slicing through Laos with the Vientiane-Botan Railway. The Iron Dragon of China is pulling emerging economies into its orbit of development. Between 2013 and 2023, Chinese companies signed over $150 billion in overseas railway construction contracts, according to the China Global Investment Tracker. These projects deliver not just economic benefits, but also strategic geopolitical influence, positioning China as an indispensable player in global transportation. Of course, brakes aren't only found on train cars, they also exist in the financial balance sheets. By the end of 2023, China Railway's debt stood at approximately 5.91 trillion yuan, $820 billion, with 72% of that being long-term bonds. However, the company's debt-to-asset ratio had dropped from 65.1% in 2020 to 63.4%, thanks to steady revenue growth of around 6% per year. The government aims to shift 15% of air traffic and 10% of road freight to rail transport by 2030, which is expected to save 70 million tons of CO2 emissions annually. However, the company's debt-to-asset ratio had dropped from 65.1% in 2020 to 63.4%, thanks to steady revenue growth of around 6% per year. With government policy fueling the engine and technology ensuring the gears stay aligned, China's rail machine continues racing forward. By 2050, the nation plans to operate a network stretching 274,000 kilometers, including a 600 kilometers per hour maglev line between Beijing and Shanghai, redrawing the continent's mobility map. Since the roar of Fuxing trains echoed beyond China's borders, the world has realized that high-speed trains aren't just carrying passengers. They are carrying political influence, capital flows, supply chains, and even votes in international organizations. A CR400 racing across the Yunnan Plateau or the Serbian plains at 350 kilometers per hour may seem less dramatic than a fleet of warships, but its soft power impact is far more enduring. By weaving a web of steel rails across continents, Beijing is crafting a new logistics order where control over trade, energy, and data is firmly tied to Chinese technology standards. At the heart of this strategy is the Belt and Road Initiative, BRI, a $1 trillion diplomatic project spanning 2013 to 2023. In BRI's blueprint, railway lines serve as the backbone. More than 19,000 kilometers of international rail projects have been signed or initiated, accounting for nearly 40% of total BRI infrastructure value. The 414-kilometer Laos-China Railway was the first to demonstrate Beijing's winning formula: concessional financing, plus turnkey technology paired with full-service operations. Travel time from Vientiane to Kunming has now shrunk to just 9 hours. Freight volume through Botan Station rose by 320% in the first year alone. Laos, once a landlocked nation, is becoming a logistics hub for the Mekong subregion, with China firmly in control by holding a 70% stake in the operating company. In Indonesia, where the Shinkansen once symbolized Asian railway prowess, China narrowly edged out Japan to build the 142-kilometer Jakarta-Bandung high-speed line. With a bid 20% lower, a promise to complete construction in just 60 months, and a $4.5 billion loan package at 2% interest, China bested a rival that had once launched spacecraft 3 times. When the Kereta Cepat high-speed train service launched in October 2023, Chinese banks had already locked in a minimum 30-year revenue stream from ticket sales, while simultaneously opening export pipelines for $6.1 billion worth of Chinese steel, cement, and components supplied by 1,200 satellite companies. On the political level, Jakarta began aligning with Beijing on issues like the South China Sea at ASEAN summits, a rail diplomacy effect unthinkable just months earlier. In Africa, China replaced narrow-gauge colonial relics with the 472-kilometer Mombasa-Nairobi line and the 756-kilometer Addis Ababa-Djibouti route. Combined, these two projects cost $7.2 billion, over 90% funded by loans from the Export-Import Bank of China, with 25-year terms and 6-year grace periods. As a result, cargo volume at Djibouti port jumped by 45%, and Ethiopia's GDP ticked up by an extra percentage point annually. These dry statistics reveal Beijing's dual strategy: earn $670 million annually in interest, while anchoring African agricultural and mineral exports to China-controlled logistics networks. When the UN voted on Xinjiang human rights issues in 2022, 22 African countries either abstained or opposed the resolution, signaling that cheap infrastructure and railway access can sometimes outweigh fears of debt traps. In Europe, where Siemens and Alstom once dominated, China has broken through along the Piraeus-Budapest corridor. In 2010, COSCO acquired 67% of Greece's Piraeus port and boosted container throughput from 880,000 to 5.4 million TEUs within a decade. From there, China financed the 350-kilometer Budapest-Belgrade high-speed line at $2.1 billion, 85% funded by Chinese loans, to open a direct trade corridor into Central Europe. When Hungary and Serbia launched the second phase in 2022, 58% of signaling equipment and 74% of the steel rails were labeled CRSC and Angang. The EU responded with its $300 billion Global Gateway Initiative. But while Brussels projects remain on paper, Chinese rails are already stretching across the Pannonian Plain. The soft power ripple of China's rail projects even reaches into global finance and data networks. According to the People's Bank of China's 2023 report, 29 countries agreed to settle at least 30% of their BRI railway debts in yuan, leveraging income from ticket sales and logistics services denominated in CNY. As a result, the yuan's share in global foreign reserves climbed to 2.86%. Still small, but double what it was in 2016. Simultaneously, China's Beidou navigation system and the internationalization of CTCS-3 signaling standards are forcing partner countries to install Chinese ground stations and data gateways, creating technological dependency similar to what GPS did for the United States decades ago. Naturally, the competition hasn't been idle. Japan offered a $4 billion government-to-government package and full technology transfer to secure the Mumbai-Ahmedabad line, 508 kilometers, against Chinese bids. The EU tightened bidding regulations, requiring transparency and environmental impact assessments, delaying China's proposed Prague-Dresden project. Still, China's construction costs, roughly 25% lower, and construction speeds twice as fast, remain highly attractive to developing countries, where infrastructure demand far outstrips available budgets. A 2022 World Bank survey showed that 68% of 78 surveyed BRI countries prioritize speed of completion over OECD environmental standards when choosing rail partners. China understands this perfectly and employs a key-in-hand strategy. It trains local staff in operations, maintenance, and ticket management. After 5 years, when domestic teams are finally self-sufficient, the dependency on Chinese spare parts and proprietary software keeps them anchored to Beijing's sphere of influence. Skeptics call this debt trap diplomacy. Supporters hail it as the iron glory of infrastructure-led growth. The truth probably lies somewhere in between, but the numbers are clear. The default rate on China's $60 billion in BRI railway loans, 2013 to 2021, is just 4.1%, lower than the World Bank's global average of 6% for infrastructure during the same period. In over 20 cases of distressed debt, China has mostly renegotiated terms by extending repayment periods or accepting repayment in natural resources, a barter 4.0 innovation that secures long-term supplies of iron ore, oil, and timber for its domestic industries. Ultimately, every kilometer of Chinese-built rail laid abroad carries a deeper geoeconomic significance than any diplomatic speech. Once Lao agricultural goods, Indonesian nickel, or Serbian textiles start flowing seamlessly across freight lines into Kunming, Guangxi, and Jiangsu, those supply chains become almost impossible to disentangle from China's orbit. This is true soft power, no coercion, just letting national interests naturally bind themselves to steel rails moving at 350 kilometers per hour. While China has mapped out a master plan to transform its rail industry, many other countries remain stuck in endless debates over budgets, technical standards, and local interests. The first lesson the world should learn from China is this: long-term planning matters more than money. China didn't start with a mountain of cash. What it had was the mid- and long-term railway network plan from 2004, a mere 50-page document powerful enough to reshape an entire industry. Everything was clearly outlined: goals, roadmaps, funding sources, and most importantly, unwavering political commitment across multiple leadership terms. Meanwhile, the United States has dozens of high-speed rail projects left dangling for over 30 years, from Florida's high-speed rail, canceled after a decade, to California's high-speed rail, only 170 kilometers completed after 20 years, with 1,200 kilometers still pending. Why? Every presidential term comes with a new policy. Every state has its own agenda, and no one dares to invest heavily in something that doesn't yield immediate returns. The second lesson: public investment isn't a burden, it's a seed for the future. Countries like the US often pride themselves on mobilizing private capital, but high-speed rail isn't Wall Street's dream project. Low returns, long payback periods, and high planning risks make it a non-starter for most private investors. China took the opposite approach. It poured $1.5 trillion in public tax money and government-backed loans into building its rail system. This investment boosted regional GDP by 3 to 5% annually, created millions of jobs, and eventually paid itself back through ticket sales, land taxes, and increased foreign direct investment. It's a virtuous cycle that the US has yet to replicate. Amtrak, the US national rail company, still begs Congress for a few $billions each year to cover losses, while China's railways alone raked in $135 billion in 2023. Another major bottleneck for the US and many developed countries is the fragmentation of technology and planning. Europe, for instance, has 20 countries with 20 different electrification systems and 20 different safety standards. A Thalys train traveling from Paris to Amsterdam still has to slow down by 30% at the border because the systems aren't compatible. China, on the other hand, embraced a simple philosophy: standardization is power. They forced all suppliers, from Siemens to CRRC, to comply with a unified national standard. As a result, train manufacturing and maintenance costs dropped significantly, and new technologies could be scaled instantly across 48,000 kilometers of rail. The third lesson, and perhaps the hardest one: mastery requires borrowing technology first. China never hid the fact that it bought, copied, and then improved technologies from Alstom, Kawasaki, and Siemens. But it didn't stop at copying. They demanded technology transfer and comprehensive training. Today, CRRC doesn't just assemble trains for China, it exports them to Indonesia, Brazil, and even the US, Boston's Metrorail project. Meanwhile, America still depends on Siemens, Alstom, and Japan for every new rail project, making it expensive, slow, and lacking in self-reliance. The fourth lesson: railways are not just about transportation, they're about national planning. Wherever China extends its railway network, regional economies blossom. The Lanzhou-Urumqi line helped create the Northwest Silicon Valley, turning barren deserts into a 300 billion FDI magnet. The Chengdu-Lhasa line transformed Tibet from the poorest region into a booming tourist hotspot. In contrast, the U.S. rail system remains disconnected from its broader urban planning. Texas wants its own line, California insists on its own technology, and Florida scrapped its entire high-speed rail project over fears of financial losses. As a result, America's largest cities still can't connect faster than 150 kilometers per hour. And finally, the biggest lesson of all, political commitment must be consistent, not just a campaign slogan. In 2013, Xi Jinping declared, "High-speed rail is China's new brand to the world." It wasn't just a catchphrase. It became a 30-year national mission embraced by an entire generation of Chinese leadership. In the US, and things are different. Obama championed high-speed rail in 2010, Trump criticized it as too expensive in 2019, and Biden tried to revive it again in 2021. Every 4 years, the dream dies another slow death due to political whiplash. China, once known for endless highways and skies filled with planes, has transformed itself into the empire of overnight trains. Blazing across deserts, forests, and oceans, China didn't just catch up, they raced ahead, and now they lead. There's no denying it. China has achieved the seemingly impossible, turning an outdated industry into a symbol of modernity, speed, and unstoppable strategic vision. Through the analysis from Top 10 Discoveries Official, have you found the answer to the question, why does China have the fastest trains in the world? Leave a comment and let us know. Top 10 Discoveries Official will be back with more incredible finds, monumental projects, and untold stories from around the world. See you next time.